Hey everyone, thanks for coming out here. We've been collaborating with the folks at Arise for a long time, and so very grateful to them for co-hosting this meetup with us. And actually, a lot of us have been working in AI for quite a long time, for 5, 10 years. Actually, I'm curious how many of you were, if you could raise your hand if you've been thinking about AI for more than, say, 2 years. All right, so what about more than 4 years? All right, actually quite a few people. So AI has changed a ton over the last few years, every single year. Um, and I'll share a little bit about how I got into AI, what we started working on, how that's changed over the past few years. And a lot of our customers and the companies that we work with here at any scale are companies that are really heavily using AI in production. And some of them are companies at kind of the frontier, building the most advanced models. And so we have some vantage point of where things are headed, and I'm interested to talk about that. So just a little bit about myself. I started a PhD at Berkeley in 2013 and focusing on AI and machine learning, and a lot of it was around statistics and optimization algorithms and things like that. I was very much working on the theory side of things to start off. The theory of proving how quickly you could learn from data, how to optimize neural networks across multiple GPUs, or reinforcement learning algorithms, how to learn faster from data, things like that. But over the course of our research, one of the bottlenecks that we ran into, we found ourselves spending all of our time managing clusters and getting our stuff to run on spot instances, things like shuffling data, all of the systems and engineering challenges around running machine learning experiments. That was where we were actually spending our time, even though the thing we wanted to spend our time on was designing the algorithms. And that gave us the idea to try to build better tools for distributed computing for AI, because AI is very computationally intensive, right? You're often running stuff on a cluster across multiple GPUs, multiple servers, and there's a lot of software engineering work that goes into doing that, into making it scalable, into making it reliable, making it performant or cost efficient. So we started Ray, which is an open source project, and our goal at the time was just to build useful open source tools and to get our friends to use it. And we were, going around the computer science department, sitting down with our friends, asking them to try it out, watching over their shoulder as they, installed it, and seeing what issues they ran into. And so that was the first. We did that for a few years, and we had no plans to start a company at the time. But as we were graduating from Berkeley, we thought, Philip and Jan and I, who are all working together on this, thought hey, we still haven't solved the problem. It's still very hard to do distributed computing for AI, and it's still an important problem. We think AI is just becoming more and more computationally intensive. There's just a growing need for scaling compute for AI, and we want to keep working on that. And some people were starting to use Ray, and so we decided to start Anyscale to try to commercialize Ray and keep investing and to work on this problem more. So that led us to start Ray and here to start the company. And here's a picture of us back at Berkeley working on the open source project. And so looking back, when we decided to start the company, we asked ourselves, are we too early or too late, or right on time? And with a startup, timing is extremely important, right? You have the right idea at the wrong time, and it's not going to work. And we asked ourselves, hey, how's our timing here? And it's very difficult to know in retrospect, right? Or it's easy to know in retrospect. It's difficult to know at the time. And we actually thought we might be too late. That AI was already, this is 2019, AI was already taking off, and we might be too late. And that was not the case. So what actually was the case was that as we were going around pitching Ray, telling people, hey, we're building this system for distributed computing to scale your AI workloads, it wasn't really landing initially. And the vast majority of companies we talked to were not really thinking about AI. AI just wasn't a priority for them. And not only were they not thinking about AI, they definitely weren't thinking about scaling AI. Right? We would get questions like, isn't a single machine enough? Like, do you really need more than one machine? Like, or you can fit 8 GPUs on a single machine. Isn't that enough? And they would say, of course, Google needs to scale things, but that's just Google. Like, does anyone else actually need to scale and like their AI workloads across multiple machines? And that was the kind of question we were getting for the first couple of years of the company. And it was really, and when we started the company, it was really just the earliest adopters using Ray. In fact, we had like one serious production Ray user when we started Anyscale, which was a Chinese company called Ant Group, Ant Financial. They make Alipay. And they've continued, for whatever reason, they decided to bet on Ray when it was an immature research project. And today they actually run about a third of their compute on Ray. I think another third is running on Spark, and another third is like other stuff. But this is everything from large GPU clusters for model serving to online learning to graph processing and batch inference and things like that. So the real inflection point for Ray came with ChatGPT, when all of a sudden overnight, AI became a top priority for just every business. And the need for scaling AI, for larger models, more data, more compute, became far more obvious. And so it was really with that inflection point that many people started adopting Ray. So we work with companies, foundation model companies building their models for video or text or whatever. We work with tech companies building their products, training their models. We work with like hedge funds, biotech companies, a huge variety of different types of companies. And really this has happened since ChatGPT. And just to share one of my favorite use cases, because it's a cool video, this is a startup called Runway ML. They do models for video generation. And if you imagine what it takes to build a video generation model, of course you're training a big model on a ton of video data. But how do you you don't just scrape the video data from the internet and then feed it straight into training. There's a huge amount of curation and pre-processing and inference that actually needs to be done to prepare that video data for training. This includes things like generating text descriptions of the videos. It includes things like judging how interesting the video is and filtering out boring videos or low quality videos. It includes things like transcription of the text. It includes a lot of classification to generate additional tags or metadata for the video. So there's a huge amount. You can imagine workloads, these like data preparation, curation workloads running on 500,000 CPU cores or thousands of H100s, maybe like spot instances scaling up and down for maybe a week at a time. Like, these are really challenging workloads to run, and often the data part of the workload can be more expensive or more intensive than the actual training part of the workload. So that's an interesting development and trend I'll talk more about in a little bit. But I show this video because like it's an example of where things are headed, right? If you think about machine learning 5 or 10 years ago, a lot of it was really tabular structured data that people are working with. Now you see a massive rise in unstructured and very like multimodal data like video. And video is interesting because it combines video and images and text, audio, and all sorts of things. Okay, so I want to talk a little bit about, we're working on Ray, this open source project. People use Ray for training their models, for serving their models, for processing data. I want to talk a little bit about some of the trends we've seen in AI infrastructure broadly over the past couple of years. And the first one I want to talk about, so scaling laws. How many of you have heard of scaling laws as a concept? All right. So this is a studied most in the context of language models, but we see people also studying this in finance and other domains as well, and video and other domains, many domains. And this is the idea. It's an empirical observation, not a law of nature, that by you training larger models with more compute on more data, you can get better results. And this is, maybe it seems obvious now. It was not obvious 5 years ago. It's not obvious 10 years ago to the vast majority of people doing machine learning. And this is great. it's very interesting to a lot of people because it's almost like a formula. It's almost a formulaic way to get better results. And as part of our work at Anyscale, I talked to a lot of ML platform leaders, a lot of ML infrastructure leaders, and many of them have told me that their top priority last year, or this year, next year, is to enable training on way more data. That might be an order of magnitude more data. It might be 100 times more data, because they're looking at this and they're assuming that if they enable training on way more data, they can get better results. And the problem, of course, with training on 100 times more data is that when you were engineering your systems, you didn't plan for 100 times more scale. You weren't planning building it that far in advance. And so you have to revamp your systems to do that, right? To make it more reliable, to make it more scalable, to eliminate all the bottlenecks. And so really the infrastructure folks, the people building and running these systems, are kind of on the critical path for releasing the next model and getting better results, right? So this like machine learning infrastructure role has become very important for the business. And at the same time, you may hear people say that we're hitting diminishing marginal returns and scaling laws have ended. There's a lot of headlines like this. And it's true that with any given technique, for example, pre-training, you may, at some point it will have diminishing marginal returns. And a lot of the most advanced foundation model companies, they are not trying to make their models smarter by scraping twice as much data from the internet. And once you've read million Yelp reviews, do you really need another million Yelp reviews? Right? At some point, there's diminishing marginal returns. And the approach to getting smarter is not necessarily scrape way more data from the internet and do more of the same thing. A lot of the question now is, how do I get higher quality data instead of just more data? Right? What does that mean? Well, how do I use AI? How do I put in more compute to improve the quality of my data? That might be by filtering out low quality data. That might be by generating synthetic data, right? That might be by, and for example, you see this in specialized domains like coding or math. You can do things like just generate data, right? Start with a bunch of math problems, try to generate a bunch of proofs of the theorem, and then you can sort of deterministically check, was the proof correct? If it's not correct, throw it away. If it is correct, you keep it, and it's like a valid data point. Right? There's a lot of ways to put a ton of compute into generating high quality data. For example, we also chat with companies in the biotech space that ultimately want to generate candidate drugs that they might synthesize and then test out, in the physical world. So you're not looking to generate a billion real physical drugs, but you may start by generating millions and millions of candidate sequences with some generative model. And then you may take each of those sequences, those candidate proteins or whatever they are, and fold them with something like AlphaFolds to get the structure of the protein. And then you may run a ton of predictive models to judge how toxic, what's the toxicity of this drug, or does it bind to the target that I'm trying to bind to, or is it soluble, and many other properties. And you can put a huge amount of AI and just like GPU compute into sort of progressively filtering the set of candidates down to a smaller and smaller set. And maybe at the end of the day, you have 100 data points that you're actually going to use. And so this is just an example of ways of putting huge amounts of compute into generating data. Now, these are all specialized domains, but I think you're starting to see versions of this in very general domains. And I think all of the frontier model labs are using synthetic data quite heavily now. So this is a trend that we're starting to see. Okay, you're not just investing in scraping more data from the internet. It's really more about, how do I use more AI and more compute to just get higher quality data? And that's going to be the path to getting smarter. That's not even touching on scaling at inference time and reasoning and things like that. That's another important trend. But there's going to be, this is like a direction we see becoming very, very important. So the second thing I want to say, and we touched on this a little bit, but multimodal data is going to be the dominant form of data. And when I say multimodal data, I'm especially talking about unstructured data like video and images and audio. And if you think about historically how businesses use data, a lot of the way that businesses collect a lot of data, a lot of the way they collect this data because they want to use it to get insights, maybe insights about their business, insights about their customers, insights about their product. And they collect this data. One of the main ways they get insights out of their data today is by running SQL queries on the data or simple analytics. And so you're going to mostly collect data that is conducive to being sort of processed with a SQL query. And it ends up being very tabular data, very structured data. But what AI does, what a lot of these models do, is that they kind of open up unstructured data and all these different types of data to being processed. Right now, if I have a video that I recorded, I can have my model watch that video. Or if I have a bunch of images, I can have, or PDFs, I can have my model kind of just read those documents and I can ask them questions, right? And so there's a large categories of data that we weren't able to do much with in the past. And so we weren't really using them much. And if we're not going to use them much, probably also not as valuable to collect them. But now that we can get value out of them, we're going to start collecting way more of this type of data and using it way more. And what's going to happen there, and of course, SQL is not going anywhere. SQL is very valuable. And these things will, and AI will really augment what's happening in the SQL world. You'll see, of course, AI generating SQL queries. You'll see AI being used inside of SQL queries. But this is really going to be a very different type of workload. If you think about previous big data processing systems like Spark or Hadoop or Flink, these are CPU-based systems. They're really designed optimized for analytics and CPUs with structured tabular data. Here, what I think will happen is that data processing is increasingly going to be an AI workload, something to do with machine learning models. And therefore, it's going to be more of a GPU workload. So it's going to be a different set of systems challenges. It's going to be a different set of kind of just workload requirements than what you have before. And if you think about AI, sort of distributed systems for AI that people have built, like the deep learning frameworks like PyTorch, TensorFlow training systems, a lot of these training systems are really, are designed for managing GPU compute, but they're not really designed for big data processing. Right? They're not really designed to solve a lot of the types of challenges that Spark might solve. And so I think there's a new regime of workloads emerging here that are going to be like very GPU intensive and very data intensive. And so I think that's something we're starting to see a lot of. It's something that I see becoming a bigger and bigger thing broadly. And the last thing I want to, yes, so one of the key questions here, previous question I was posing around scaling was, how do I, instead of just focusing on getting more data to make my model smarter, how do I use more compute to get higher quality data? And I think a second key question here is just, how do I use AI to get insights out of my data? Right? And that's going to look very different from how we get insights today. So the third thing I want to point to is heterogeneity. This is Spark. If you think about the way systems like Spark and Hadoop and everything were built, they assume a uniform set of machines, right, that all kind of look the same. Same with deep learning training systems. A lot of these already systems assume you are working on a uniform set of machines that all have the same number of GPUs and all the same type of GPUs, and you just run the same computation on each one, and then like aggregate the gradients and then keep going. What we're seeing now with a lot of these workloads is that a huge amount of variety, right? First of all, there are many types of models people are working with. Large models, like LLMs that span multiple GPUs or multiple machines. Small models, people are still, still have their recommendation models and ranking models. Those aren't going anywhere. You have many different types of hardware accelerators. Of course, NVIDIA is dominant here, but all the cloud providers are building their own chips to try to remove that dependence on NVIDIA. And I think you're going to see a really competitive ecosystem there. And if you're a business trying to think about, like, what are we, what kind of hardware are we enabling or using internally, you're not going to want to lock yourself into one choice there, right? You're going to want to architect for flexibility. At the same time, the types of data people are working with are becoming more and more diverse, right? So it's structured data, but every organization is going to have, of course, text and PDFs and video and all of these types of things. If you, maybe the way your customer support works today is text-based, but it's very natural to augment these applications with photos, like with images. If I, am returning some package to Amazon, I want to take a photo of that and show what the problem is, or things like that. I think a ton of use cases will end up being very multimodal once we have the capabilities to work with that type of data. And so the point I would make here is, if you are building systems for AI or thinking about your AI infrastructure or platform internally within your business, I would think about architecting for flexibility, because there are going to be new models, new types of data, new hardware accelerators, and generally you're going to want to position your team to take advantage of the latest capabilities and tools as soon as they're available. So these are some of the things we see happening in AI right now, and in the infrastructure layer right below the AI applications. I think the last thing that I want to share here is just one blog post from Amazon. This is, self-promotional here, but Amazon wrote a blog post about how they migrated one of their large-scale data processing workloads from Spark to Ray. This is Amazon has a ton of data. This is actually an exabyte scale workload. And later on in the blog post, they talk about how by doing this, they're actually saving over $100 million a year. And so I like to share this because I think it's a very impressive use case. And of course, Amazon is a unique company with a lot of unique challenges, but there's going to be far more data being collected and processed in really not just data intensive ways, but compute intensive ways going forward. And so I think this is a very exciting example. All right, I'll stop there, hand it over to Jason. Thank you all so much.
Thanks for having us here, Robert. So a question for all of you. Raise your hand if you've been in ML or AI for more than 10 years. Really? Wow. What about more than 15? Okay, this is gray hair. This is from it. Amazing. Well, I think it's good to have all the new folks interested. Cool. So give me a second here So if you haven't heard of Arise, we're observability evaluation, so unified platform that observability and evaluation leader. Let me see. Okay, there's him. We have Phoenix, which I'll tell you a little bit about tonight, which is an open source.
Join the meeting.
Yeah, I think I just did that. Maybe didn't the zoom up. Oh, that's weird. Maybe I clicked the wrong link. Sorry. 1 second. Do I not have the Zoom? Do you want to just email it to me, Jason?
I can just do some Q&A while they.
Okay. Yeah, do some Q&A.
All right. While we're setting up over here, does anyone have questions? Yeah.
But I think that the trends are like it because what they don't reflect the vision of the future, but they never act on it themselves. So after you got the future of things, I gradually put together and all the right ideas and all the truth, all the professors are high quality professors, just like Stanford or MIT. I was wondering, what are your views about that? You're handling data large data, structural data, unstructured data, and we have all kinds of databases all over the world. The access is there. There is always a fight between the software and the hardware. The hardware is always, I think, sometimes the hardware and software are not in sync right now.
Yeah. So hardware and software right now are not in sync, and there's some tension between them. I mean, I think with AI, there's going to be a massive infrastructure build out to really enable AI, all the kinds of AI applications that people want to build, right? And I think this has been true with previous tech waves. If you think about the internet or mobile or the cloud, there's a massive infrastructure build out, and that includes hardware infrastructure and a software layer as well. And they're both extremely important. I think today with AI, you see this very clearly on the hardware side with NVIDIA, right? But you often need a software layer on top of that to really, which often comes later, to really make that programmable, usable, performance. And I think that part is like is wide open right now. Okay, back to you, Jason.
Little technical setup there. So we're going to talk today. I guess how many of you have obviously heard of evals or evaluations? Or is it like, oh, yeah. We did this. So we did one of these probably this time a year ago. So Phoenix, our open source solution, had evaluations like probably over a year and a half ago, and we mentioned this in the room, and you get like 2 or 3 hands, and so it's awesome that it's like become mainstream. What I'm going to do today is audio assistants. So agents and assistants are big within our customer base. We have a whole set of customers who are now testing the real-time audio APIs. And today I'm going to talk to you a little bit about audio evals, which is the idea of running evaluations on audio itself, which we've released in Phoenix. I don't know if it's official this week, but it's coming in at least the next week or so. So first off, have any of you used the real-time audio API from OpenAI or others? Okay, a couple handfuls. I mean, it's pretty impressive, and I think the vision here is there's an incredible amount of audio conversations that occur. Over 1 billion conversations occur daily just in call centers. I mean, I don't know, it's all those phone problems or whatever, but it's an incredible amount of incredible amount of support, which is perfect for AI. Incredible amount of assistance or areas where just AI can help, and these new AI models are perfect for. And if not just thinking about replacing call centers, but I don't know if you've all seen the movie Her. I'm also dating myself, being an AI forever. Love this movie. It's about AI assistant, which is audio based, where you can talk to her, and Her doesn't just talk to you; it talks to 10,000 people at once. Which is, imagine all of these applications you can create when the models don't just understand text as tokens, but understand audio as tokens or video as tokens. So there's a vision here for stuff that's really powerful. I have some customers who do travel assistance today, which customers include TripAdvisor, and these folks bookings. All these folks have trip planners and assistants, and there's a lot of reasons to make these like hand-free and easy, and just give me something to talk to. I think there's views around education. We have customers such as, say, Duolingo, who does language, and there's just a lot of ways in which, as you envision the future, how these are going to look. Well, how do these real-time APIs work? Well, the real-time APIs, I don't know if you've used them, but you can configure them to deliver both the transcript and the audio chunk. So it's kind of like the streaming event-based interface that you use, and when you talk from your side, it gives you back a chunk of the audio, and it gives you their transcription. So you get a little text chunk and an audio chunk together for every back and forth of the audio conversation. which is really nice because you have both together. And as a platform that does observability, evaluation, helps you debug, having both of these is really powerful. And I'm going to go into like how what you might want to do. The example we have is like detecting motion or call quality. There's a lot of things you can do on top of audio. What does real-time audio look like? I don't know if we have the audio on this, but basically, you have audio kind of talking back and forth, and you kind of have events going back and forth. And this is the OpenAI version, where there's little snippets, and each one of those has a chunk. And each one of those is a little snippet with a chunk of transcript and a chunk of audio. I'll show you a little bit of like how this works in our system. It's a little more detail. There's a a socket created from the client side. There's there's quite a bit here in terms of events where it's event based and you're listening for events. The events kick you off, and those events are sometimes things like getting the transcript back from the server side. There's a lot of stuff we have on event-driven architecture. Most of this is going to come into your app when you're building it. We have to handle it a bit ourselves as we're an SDK, like a little SDK collecting the events too to give you debugging abilities. But for the most part, these are event-based. And so the most important thing is, what about evals? What is an audio eval? What do I even mean by that? Well, an audio, like in a traditional eval, you're putting in text, and that text can be a conversation. Sometimes we use session evals. Is this conversation good? Question and answer evals. I have large. I have people doing code generation for in product stuff with code evals. Well, in this case, now you have an audio chunk. It's an audio file. You put it in, and what do you want? Well, normally the question is like, from an evaluation, you're trying to understand performance. You're trying to understand an outcome. And sometimes I see customers do evals at like a technical level, like did it call the right tool, or I see them doing it maybe a little bit more product level. Is it answering the question correctly, or is the person frustrated in the conversation? So the example here is what we'll show you is detecting frustration in audio signals and audio calls. But you can write a template. So the audio eval template is describing what you want to detect in audio. Is someone embarrassed? Is someone lying? I don't know. Is someone emotional? Like is the audio call, is the call bad? So there's basically and so in the audio signal itself, there's quite a lot that you miss in the text. And it's not always. I mean, I think there's a good argument for a lot could be done in text. So the real question is like how much, where to add this. But a lot of our customers are wanting to add stuff around things that you can't detect in text. So the way it works is there's there's audio that goes in. There's some eval, which ends up being text, which is what a prompt template looks like for that. And then there's some output that helps you pinpoint whether the thing's correct or not, or whether the thing's like what the problem is. The way it looks is something like this. I don't know if you can see that, but what you have is you have a prompt template that's kind of for your eval. This is an emotion detection evaluation. And here it says you're a helpful AI bot that checks for the tone of the audio. Analyze the audio file to determine the tone, whether it's positive, neutral, or negative. Your evaluation should provide multi-class label and an explanation typically. So why did you think this person was stressed out or whatnot? So you are leveraging now evaluations on top of audio signals that are running your system. For voice assistance, this will be important. You want to know if it's confusing, if it's actually saying the right thing, if it's translating correctly. There's quite a lot you might want to do. That's the audio portion versus the text portion of the assistant. I'll show you a little bit of like what this looks like. So give me a second. What does this look like in practice? So first off, I do want to give a plug for Phoenix. So we have Arise has like Arise kind of AX the main enterprise platform, but we also host Phoenix. We're at 4640 10 more stars, I think 47. So if you're here and you like it, give it a star, please. Our team eats on stars. This from inside Phoenix, there's documentation here on how to run evals. Inside here, there's kind of different sets of evals that you might want to do. And inside here is where kind of the audio evals are. Phoenix also has a visualization layer, but I'm going to kind of show you a little bit of what it looks like in code first before kind of going up to there. So first off, typically what we're doing is getting data. In this case, it's some audio file around some conversation. There's an emotion detection template I was talking about, which here is just, again, a text description of what you want it to eval. What is it you're trying to determine is correct in your system? What are you trying to determine about the conversation, the audio conversation? Again, it could be call quality, emotion, confusion, stress, you name it. And so this kind of describes this example of what you are an AI system designed to classify emotions in audio files, analyze the provided audio file, classify the primary emotion on these characteristics. So this is just us, an eval we came up with. Some of our customers come up with different ones that helps you understand and define what this is. There's a little bit of setup in code here of how you set it up. You got to have your audio files somewhere. In this case, we're doing it in Google Cloud. And you run here's the line of code that runs the GPT-4 audio on top of the transcripts and audio files that came back. Piecing it all together, as you kind of want to look at the whole thing together. Let me do this first. So I'm going to give you a little bit of a demo of like what this looks like so for a normal assistant, AI, for a normal assistant, you get traces that look like this in our platform. So this is the Rise Enterprise. We have a Phoenix version that's open source, collects traces. Now for audio, which for audio, let me go back and show you what an audio looks like. Sorry. Oh, there it is. So for audio sessions, you end up getting this snippet. So when that back and forth occurs, as those events are getting traced, we're catching snippets of audio. I don't think you're going to be able to hear this one, but you get a transcript for what it was, and you get the audio file back you can play. So you're capturing little traces and snippets of the back and forth real time. And you can see here we've run our eval, which we have a whole there's a whole idea of online or offline evals. Have any of you know the difference or ever heard kind of the idea of online evals or offline evals? What I mean by online eval is just that it gets processed in our system. Like normally offline, I mean, there's a little snippet of code there, maybe it runs in Python, maybe it runs in your system. Online typically means we're ingesting the traces and we're running the models on top of the traces as they're ingested in our platform. And you set up the model, you set up the prompt, but it's run in our platform just as data flows in. So the example here is that this eval here was run. You can see an eval here. I can search on it. I can hop over to the eval here. You can see kind of what this is. There's a label here, neutral. There's a frustrated label I'll show you in a second, but it gives you an idea what the AI thought was happening. It gives you an explanation. The tone of the speaker was calm, low, and steady. This is why I think this is it. So it gives you an idea. Also, and we build this into the templates that give you a little explanation of what it thinks this eval is. So you could then obviously search on certain evals. Frustrated, for example, I can. And in this case, I'm looking for like frustrated evaluations and so you can search through all your calls, your moments. You can pop back to where the person's, where it's frustrated, what was happening. You can go back to the full session conversations. In this case, pretty small session, but what was the back and forth prior to that? So the whole idea is as you're building assistants and agents and voice-enabled applications, you need obviously. I mean, it's really hard to build, I think, without observability. It's really hard to get this stuff to work well without evals. So hopefully this gives you an idea of this. Any any questions? We kind of ran through a lot. Feel free to. Um, yeah, so this was a test set where the person was trying to, on purpose, be frustrated. Like it was a little bit of a test data set, but agree that the text doesn't actually convey it, but the voice tone actually does. Just can't play it for you there. Yeah.
Using LLM with a template prompt to basically classify, and come up with the eval. Did you compare it to some sort of neural network or like a supervised multi-class classifier?
Yeah, I mean, my general take is you can make that statement of all evals are. I mean, all evals are generally a supervised problem, just using a general purpose LLM to do it. I think the power of the LLM is just the fact I can, like, people edit their eval prompts on our platform 5 times a day. I have someone who adds 20 evals to something. Like, you just don't want to constantly train these supervised models. You just want to drop a text is so nice. Describe what you want your system to do. So good question. My bet is you could probably beat a lot of this with a supervised work. It's just not worth the operational workflow to do it. Yeah. Go ahead. Go ahead. Go ahead. Yeah. On the what level? Yeah, so this example is on the actual audio file itself. So these are audio evals where we've had text level evals for a long time. So this is like using audio based models the audio based models to run evals on the audio stream. So it's looking at the waveform exactly, and basically these audio models are trained with tokens of both text, audio at the same time. They know both language and the tone, intonations, and how they're combined together. So they're pretty powerful in understanding what the speech itself. Yeah. So Phoenix, John's here. I think John will tell us when this is coming out in our docs, but I don't think it's out yet in the docs. Okay. Yeah, we launched it, just no docs yet. Go ahead. Yeah, good question. Yeah, good question. So Phoenix, which is open source, obviously you just run on your own data, and and in Phoenix's case, you just point to there's this, I think it's a data source, and it could be Google Cloud. And basically, I think we support some of the cloud providers or examples of the cloud providers. So hosting in there, how to point it. So it's running in your system on your data. Arise, obviously, have both a SaaS platform and a VPC, which will deploy in Infra for high security clients, which is a lot of them. So we have a lot of options for the enterprise that either deploys on your data or SaaS. But either way, we're pointing to files that you host somewhere and authenticating to get them. Yeah. I mean, it's a really good question. I think the question's I think the question's even beyond voice, which is, can evals be used at inference time to improve a system? And Google's Mind Evolution, actually, if you look at their paper, they do that. So that's a new paper worth taking a look at. I definitely think there's a future of evals inline and inference to improve in either in Google's paper was a big parallel generation of prompts and a search decision on it using evals, but you could do RL loops there too. So I think yes. The answer is probably yes. We're pretty early stage in the stuff where it feels like no, I haven't seen people doing it in practice yet. But yeah. Yeah, I mean, so Arise tends to be, lean a little bit heavier a lot heavier production. So think of it as maybe production and enterprise. So the bigger you are, the more likely Rise is going to be. And so the Rise AX platform, massive scale of data. I mean, we have the Uber, Instacart, Etsy, of the world. The Phoenix is going to be is going to be typically smaller teams, smaller data scale. In terms of online evals, Arise, since it's always running in its production, has online evals now. Phoenix doesn't, but I'm sure we'll add. The team's looking at adding it. So online evals are this always running process that augments it. In Phoenix, you're kind of running the evals yourself and pushing it into Phoenix. Cool.
I know there are a lot of other monitoring and eval frameworks out there.
Yeah.
You think Phoenix does better than, say, for example, like Infra, at least I think so.
Yeah, I mean, I think so Phoenix, first off, we invested a lot originally in tracing, meaning instrumentation. So we are both platforms share the same instrumentation. So OTel, so standard instrumentation, capturing traces. We support probably 20 different frameworks right now. So just collecting the data, I would say, is the biggest, is kind of one of the biggest differences. So trace, the ability to kind of trace an instrument and capture that data in the first place. We now have Prompt Playground. I don't know if Weave has that. We now have Prompt Hub. I don't know if Weave has that. We now have, there's workflows. Sorry about that. I do have somewhere to be. So I think like there's two, I would say open source solutions when you look at it tends to be probably, I mean, I'll just say Phoenix and Link Fuse are probably the two. Link Fuse tends to be a broader, like Phoenix is just easier to install, easier to get going, easier to get live, and Weave doesn't honestly come up as much. I don't think it's as competitive right now. Yeah. 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 Nice comparison there, but we're continue to invest heavily in this, and then there's a lot of shared infra, like the fact that the tracing instrumentation, can't emphasize enough how much instrumentation matters as you get to something that is anything production ready. Yeah, and so we invest tons in that, and the eval. I do think the eval investment we have here too is just not a strong comparison with other sets, but yeah. In terms of, sorry, which models do we have besides audio? Yeah. Yeah, I mean, by far eval and text, text streams is by far. I mean, I have individual customers, spending millions of dollars a month on text evals for their product lines. Like there's a lot of scaled evaluations being run right now, and it's just people are realizing I can use it to evaluate whole product, experiences for some of the stuff. Not the whole experience, but you can get at really interesting questions around, is this doing what I want it to do? So I think LM as a judge tends to be used a lot more than code evals is what I see, although I do see some amount of code evals. But I do have to get going. So last question. Yeah. So the question, yeah, so this one's a general one. I mean, we have we have a lot of examples with general LLMs, this combined audio and text for the eval model here. This one, I think the big thing you're going to want is just a model that does both text tokens and audio tokens together. That's probably the big ask. And then there's probably a lot of different ways you might then go do, maybe you fine tune or find a small one, or like there's some industry approaches like that. But this example is just using the general one. I do have to hop here. John from your team is here, so grab him too. He's that did most of the hard work behind this. I just make them look good. Great to connect all of you.